Welcome to 12.2, volumes of prisms and cylinders. These are your formal theorems and formulas. So you can check back on this if you want. Let's find the volume of the prism. So you take 4 times 2 times 1.5. So 4 times 2 times 1.5, and you get 12 meters cubed. All right, number 2. The face of this is, or the bases are trapezoids, so 1/2 times both bases, 1.2 plus 2.3, times the height of the trapezoid. Here's your trapezoid. And then you take that times the height of the prism. All right, so 1.2 and 2.3 is 3.5, times 1.8 times 2, divided by 2 is 6.3 centimeters cubed. Now we have a triangular base, so this is 1/2 the base times the height, and then the height of the prism. So 1/2 of 70 is 35, so you take 35 times 5, and you get 175 cubic inches. Now this is a rectangular base, so 6 times 11 times the height, 14. So 66 times 14 is 924 cubic meters. Okay, find the volume of the cylinder. So pi r squared, so pi times 3 squared times the height, 10.2. So 9 times pi times 10.2. And we get 288.398. So it's 288.40 cubic feet. And then number 6, pi r squared, so your radius is half of 26.8, and that is 13.4. So pi times 13.4 squared times 9.8. So we square the 13.4 and multiply it times pi, and we multiply that by 9.8. And you get 5,528.22 cubic centimeters. Number 7, again, pi r squared. The radius is 5 times the height. So 25 times pi times 8, and that gives us 628.32 cubic feet. Same thing on number 8. The radius is 6, so pi times the radius times the height. Now the height's not 18, so we got to get this height here. So the hypotenuse of this right triangle is 18. So we can use the opposite leg and the hypotenuse. That's sine for SOHCAHTOA. So the sine of 60 is equal to the opposite leg over the hypotenuse. So multiply by 18. And 18 times the sine of 60 is going to be 15.6. 15.5 ... Okay? Times 36 times pi. So 1763.01 cubic meters. Okay, number 9, sketch the solid formed by the net. Okay, well, so what do we have here? We have 2 side triangles. This would be the back and the front here. That's those 2. Then we have this little side piece. So that's going to be, let's do it this way, 2.5, and this will be 1.5. And then this is 4. All right, so then the volume of that is 1.5 times 2.5 times 4. And that gives us 15 cubic units. And what do we do wrong here? Let's do it first. So the area of the base is pi times 4 squared times the height of the figure, 3. So 16 times pi times 3 gives us 150.80 cubic feet. All right, so what did they do wrong? They did 2 pi r. Well, 2 pi r is the circumference of a circle. So they didn't use the area of a circle formula. Okay, number 11, sketch the solid and find its volume. So we have a prism, has a height of 11.2 centimeters, an equilateral triangle for the base. So there you go. You have an equilateral triangle for the base. So that means 60, and every side is the same. All the angles are 60, 60, 60. Okay, now where each base edge is 8 centimeters, so this is 8. All right, so the height of this prism is 11.2. All right, so this is what it looks like in number 11. So now how do we figure out the area of this triangle? So we need to get this information. So that's a 60-degree angle there, and there's 30 degrees here. So what do we have? This is, if the whole thing is 8, the side, so that means this little piece right here is 4. So how do I get the altitude there? So again, opposite over adjacent. So that would be tangent of 60 is equal to the opposite leg over the adjacent leg. So we multiply by 4, and we get the height of that triangle to be 4 times the tangent of 60. On your calculator, and that's 6.92 93 really. Okay, and then, so that is the height. Now, what is the area of the triangle? 1/2. The base is 8. The height is now 6.9282, blah, 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 blah. So that will give me the area of the triangle, and then times 11.2. Okay, so let's take that long number, times 8, times 1/2, 0.5, and multiply that by 11.2. And we get 310.38 cubic feet. All right, so let me erase part of this. So pause it if you need this. And I'll just do this. Let's move everything. Let's just erase it. All right, number 12. What do we have in number 12? A pentagonal prism. So first of all, let's talk about how to get this. The answer is 139 something, I think. So here's how you actually do this. If you make triangles from the center, that means there's 5 identical triangles. So if I take 5 times the area of a triangle, 1/2, base times height, okay, that would give me the whole area of this pentagon times the height of the prism. Okay, so the height of the prism is 9, and the base edge is 3. So again, just like the last problem, we're going to have to figure this height out of this individual triangle. And again, so what do we get here? We got to figure out this part. There's 360 degrees in a triangle. If we divide it by 5, you get 5 of these angles. So 360 divided by 5 gives you 72 degrees. So let me draw this out here. This is 3. We're dropping this down. This whole side here, this whole angle is 72 degrees. So this little angle here is 36. We want H, and this whole side is 3, so that means this is 1.5 down here. So just like the last problem, we have the opposite and adjacent. So the tangent of 36 is equal to the opposite leg over the adjacent. So now we multiply by H, and then we're going to divide by the tangent of 36. So 1.5 divided by the tangent of 36 degrees. That's going to give me 2.06 ... So what is the area of one of these triangles? So 1/2, the base is 3, and the height we just found, 2.06 ... So take that big long number, 2.06 times 3, and divide it by 2, and you get 3.0968, blah, 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 blah. All right, so that's the area of this triangle. And how many do we have? We have 5, so multiply that by 5. And that will give us the area of the whole pentagon. So 15.48 ... times 9 for the height of the prism. So times 9 gives me 139.36 cubic feet. All right, find the missing dimensions. So we have volume equals length times width times height. The volume is 560. Our length is 7. The width is 8. We don't know u. So 56 times u, or divide by 56, and we get 10 is u, 10 feet. Number 14, again, same thing. Volume is 2,700. And that equals the length times the width times the height again. So 12 times 15 is 180. So we're going to divide by 180. All right. And the volume is, V, not volume. V, the side length, is 2,700 divided by 180. That gives us 15 yards. Number 15. The area of the triangle is 1/2 base times height, and then times the height of the prism, which is W. The triangle here, we have 1/2 times 5 times 8, and it's times W. That would be the volume. The volume is 80, so 80 equals half of 40 is 20 times W, divide off the 20. You get 4 centimeters for W. So here we have a hexagon. So the volume is 72.66, and we have the area of the base times the length. So again, we have to figure this out, a hexagon. So let me just draw this. Whenever you're doing this sort of thing, just draw a triangle and divide it by how many sides you have. 360 divided by 6, so that's going to give you 60 degrees. So here's that triangle. Okay, this is 2 inches here. If we drop this down, this whole thing is 60, so this is 30. And we got the height. This is going to be 1 unit. So what do we have? Opposite and adjacent. So the tangent of 30 degrees is equal to the opposite over the adjacent leg multiplied by h. H is equal to 1 over the tangent of 30. So you put that in your calculator. 1 divided by the tangent of 30 gives me 1.732 blah, blah, blah. All right, so that's h. So what is the area of this triangle? 1/2 the base is 2, times the height, 1.732. So half of 2 is 1, 1 times anything. That's going to be the area of one of these triangles. How many triangles do you have? Well, 1, 2, 3, 4, 5, 6. Multiply that by 6. And you get 10.39. So this is 10.3923x. So take 72.66 divided by the 10.39230485. And x would be 6.99. So x is 6.99 inches. That should be the answer. Okay, now we go to the volume of a cylinder. Pi r squared times the height, that's your volume. They give us as 3,000. Pi, the radius is 9.3, so we got to square that. And y is our height. So 9.3 squared times pi equals 271.72 y. So we're going to take 3,000 divided by that answer, and we get 11.04 for y. 1696.5 equals pi times the radius squared, which is z, times the height. So we're going to divide by 15 pi. Okay, so 1696.5 divided by the group, 15 times pi, and we get 36.0008. That equals z squared, so z is going to be equal to the square root of that, which is just going to be 6.00. And this is meters. 19, find the volume of the composite, meaning find the volume of all the figures. So the top figure is 5 times 2, okay? So length times width, and then we need to know how wide this is here, okay? And it tells us that that's 3. So 5 times 2 times 3. We're going to add it to the volume of the bottom box. 10 times 6 times 2. Length times width times height. So 10 times 3 is 30. 60 times 2 is 120. So that's 150 cubic feet. The bottom one here is 4 times 4 times 4. Plus, what do we have at the top? We have half of a cylinder. So if this length is 4, then the radius is 2. So we have pi r squared, or radius squared, 2 squared, times the whole length of the cylinder, 4. But we only have half the cylinder, so we got to divide it by 2 when we're done. So what is that? 2 squared is 4, times 4 is 16. 16 divided by 2 is 8, so take 8 times pi. All right, so you have 4 times 4 times 4 plus 25.13 dot dot dot. So 4 times 4 times 4 is 64. So we got to add that together and we get 89.13 cubic inches. Okay, number 21, we want the composite here. Now what they're trying to say is the center cylinder has been taken out. So this, think of it like a toilet paper roll on the side here. The center has been cut out. So what we need to do is get the volume of the big cylinder and subtract the volume of the small cylinder. So find the volume of both of those. All right, so the big one, so big minus small here, the big one is pi r squared times the height, and so is the small one, pi r squared times the height. So let's just fill everything in. Pi, and the radius of the big one is 8 inches, so we got to square 8, and the height of the cylinder is 11. And the small one is pi, the radius is 3, and the height is still 11. So you put that on your calculator, and you take pi times 64 times 11, and we get 2,211 dot 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 dot. And now here's how I'll do this so that I keep that long number on my calculator. I'll put a parentheses here, and then I'll take, minus parentheses, pi times 9 times 11, and then I hit the parentheses to close it. All right, and that comes out to like 311 dot 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 dot. So hit equals at that point, and that'll give you your total, 1,900.66 cubic inches. Okay, so the same thing is on number 22. They have that prism cut out of this bigger prism. So again, do the exact same thing again. So the formula for a prism is length times width times height. Okay, so we have 4 times 2 times 5, and we're going to subtract the inside one. It's a square prism, so 1 times 1, and again, the height is 5. So we have 8 times 5 is 40, minus 1 times 5 is 5, so that's 35 cubic feet. All right, number 23. We are comparing the solids here. They're similar, remember? So we have to find the scale factor. Find the surface area and volume of solid B. All right, so first of all, we'll do the volume here. We didn't talk about surface area, but it'll be pretty simple for you. Okay, so remember the volume of B is to the volume of A, as the scale factor, K, is cubed. Okay, so we're getting smaller. So the volume of B we don't know, and the volume of A is 216 cubic centimeters, and that equals our scale factor. So since we're getting smaller, find the two sides that match, 3 and 9, put the smaller number on top. So 3 over 9 reduces to 1/3, and we're going to cube that. So we get the volume of B over 216 equals 1 over 27. 3 times 3 times 3 is 27. So we're going to cross multiply, and then so that means we're going to take 216 divided by 27, and that gives us the volume of B to be 8 cubic centimeters. Now to find the surface area, it's actually very similar. So it's the same type of thing. The surface area of B is to the surface area of A, as the scale factor is, and we're dealing with area, so this would be squared. So the surface area of B we don't know. The surface area of A is 264, and the scale factor again is 1/3, but we square it because we're dealing with area. So now that surface area of B is over to 264, and that's 1/9. So we're going to take 264 divided by 9, and we get the surface area B to be 29.33, and that's square centimeters. And the book has that as 29 1/3, just in case Big Ideas is having a cow. Okay, next one. So same type of thing here. We're getting bigger here, so the scale factor is going to be 15/12. We reduce that by 3, we get 5/4. Okay, so the volume of A is to the volume of B, and since we're getting bigger, that's 5/4. We're going to cube it. Same thing with surface area. Surface area of A is to the surface area of B. Oops, we need to make the B on top there because the bigger number's on top. Okay, and that's 5/4 squared for the surface area. So what do we have here? The volume of B we don't know. The volume of A is 4608 pi equal to 5 cubed is 125 and 4 cubed is 64. So we're going to take 4608 times 125 and then divide it by 64. And notice I didn't put the pi in there, so we get 9,000 pi. And if you put the pi in there, times pi, you get 28,274.33. And that, in the book, it leaves it like this. Okay, so now we do the surface area. The surface area of B we don't know. Surface area of A is 1,056 pi. And 5 squared is 25, 4 squared is 16. So again, 1,056 times 25 and divided by 16. So the surface area of B is 1,650 pi. And that's square inches here. This is cubic inches here. All right, and here are your answers. So that matches what they have. So good job.